Our group specializes in better understanding a class of materials called quantum materials. These are solids in which the quantum mechanical properties give rise to exotic types of electronic properties, which are of interest for future electronic devices. I'm an expert in using X-rays to better understand the fundamental interactions underlying these properties in order to better tune them for future devices and technologies.
Yeah, so this is one of the few places in the world where we can do these kinds of experiments. We're doing what are called time-resolved RIXS, or resonant inelastic X-ray scattering experiments, to look at the electronic structure of different materials. So we're looking at these copper oxides, which can be superconducting, and we're really focusing on how the electrons are shared between the copper and the oxygen atoms to try to understand how these materials have the unique properties that they have. And to do these kinds of experiments, we need really high energy resolution to resolve the energy differences of these different states, but we also need really high time resolution to look at how these states change when we excite the material with a laser. And this is one of the few places where you have both of those things at once to be able to do these kinds of studies.
Our group, like many in our scientific community, are interested in using the physics of the materials to realize new electronic properties and devices. This issue of the bonding between different electronic states is a fundamental aspect which defines electronic properties of materials. If we can modify this, we can leverage this understanding in order to be able to realize new types of electronic states with improved properties.